Hello everyone, welcome back to the channel. Today we're going to be filming a short video. The topic of the video will be how to pass linear algebra. But the tips I'm giving you today also apply to plenty of other advanced math courses, real analysis, abstract algebra, general topology, other things that your university might offer that are, above the 200 level. Even though linear algebra is typically at the 200 level, it's where some abstraction starts to come in. I figure this is an appropriate topic with the semester coming up. Most of you probably registered for classes, although you probably haven't started studying. So let's give you some good tips right at the start of the semester, okay? So the first tip is to read the book before lecture. Now, it might sound redundant, right? You go to lecture to learn the material, so why are you looking at the material before you go to lecture? Well, this sort of has things wrong, in my opinion. Let's think about the semester. Typically, you'll be getting 2 to 3 lectures a week. At most universities, that's going to total up to about 2.5 hours of instruction time per week. And that a typical semester, if you take out the class days where you're giving exams or taking the final exam, that's going to total up to about 12 weeks in the semester. Now, 12 times 2.5, that's 30 hours of instruction in a semester. This is a linear algebra book, okay? It's not atypical. I have other examples. This is also a linear algebra book. It's about 400 pages long. Theorems, definitions, proofs, computations. It's not 400 light pages, it's 400 dense pages. Covering all that in 30 hours, it's not going to happen. You're not going to get complete coverage. So your duty really is to make sure that you understand the material that should be covered in a given lecture before you attend the lecture. And the lecture should serve to reinforce the understanding that you already have. This is the type of arrangement that's going to lead to success in the course for you. If you already know the material, you'll get much more out of the lecture. If you're just trying to put it all together in your head, well, you're going to be in trouble because your brain is going to be moving so fast to try to get every little bit of information that you're going to miss a lot. It'll be inevitable. So really, if you want to succeed, I strongly recommend that you read the book before lecture. Let's go on to tip number 2. It's in a similar spirit to tip number 1. Read the definitions, theorems, and proofs until you understand them. So it's very common when people are sort of approaching math that they try to read a definition like a line of prose in a novel or something. And this is not going to work for you. They'll read it like that, and then they don't get it. So when you read a definition, or a theorem, or even a proof, it's important that you understand every little bit of it, right? How all the pieces fit together. If you're not sort of following the logical steps through to the finish, then you cannot expect to be able to write a proof yourself, right? We learn these things by doing, right? And we learn these things by watching, right? And it's important to watch in the right way, right? If you're just flying through to the end of the proof, you're not going to understand it. You got to really make sure that you follow each little logical piece and see what it implies about the next piece and how it fits into, the overall scheme of what you're trying to prove, right? And when you have to start writing proofs yourself, you're going to be in big trouble if you don't even understand them when you read them. So read them very carefully, and that applies to definitions, proofs, and theorems. It's very common, for example, towards the end of the semester, you can ask a student a basic question like, put this matrix in reduced echelon form. and the student does not understand. They can't do it. The final answer isn't even in reduced echelon form. Why do these things happen? Well, a lot of the time it's because the students don't understand the very definition that they're trying to work with, right? In upper level math courses, maybe every question that you'll get asked will rely on you understanding some given definition involved in the question. So this tip is particularly important. Make sure you read these things carefully. All right, here's tip number 3. Do the exercises in your book. So if we open up this book, right, and we look at the end of a section, we'll find that there are a bunch of exercises, right? If your instructor does not give you your own set of exercises that they make up themselves, then you better be doing those exercises that are in the book. First of all, I would never do this myself, but it's fairly common that lazy instructors will assign exercises from the book with the numbers changed around on their quizzes, their homeworks, their exams, right? And so if you are doing all the exercises at the end of the section in the book, you're going to be better prepared when it's time to face sort of analogous problems on the quizzes and the exams. Another thing to keep in mind is your instructors are professional mathematicians most of the time. And so there are no professional linear algebraists. There are no professional real analysis one-ists, right? They're analysts, they're algebraists. But most of the time, this is material that is going to be review for the instructor as well. Okay, they don't really remember how to ask questions about linear algebra. So they're looking for the book for help, right? So if you can learn to sort of speak the question language that the book is speaking, you'll probably be at a great advantage, right? Because you'll be getting it from the same source as your instructor. So do the exercises in your book, unless, maybe your instructor gives you his own homework, his or her own homework. So that will help you a great deal. Finally, number 4, enjoy yourself. Now, how does somebody enjoy themselves in linear algebra? It's a good question. But it's really common that you'll hear people in the everyday world say, I wanted to be X, Y, Z until the math got too hard, right? If you're in linear algebra, you're probably already past the point where the math gets too hard for most people, right? So try to take a little bit of pride in that, You've put in a lot of good work and you're getting things out of it, right? It's going to be very difficult for you to sit down with the book and study it if you harbor a personal resentment toward the material, right? I see a lot of people who say, I hate math, or they get sort of angry about not understanding a problem, and then they go on to struggle because they have the wrong approach to the material. If you can stay positive, it will help you a great deal. It won't feel as bad to sit down and study the book. It won't feel bad that maybe this doesn't come perfectly natural to you, you have to work at it, right? Try to feel good about the fruits of the work you've put in, however small or large those fruits may be. Don't enjoy it too much, obviously. Don't do anything crazy like majoring in math or something. That would be a huge mistake. But, I would say try to take some pride in the fact that you are learning advanced math. Not everybody can do that. There are a lot of people who can, but there are a whole lot more who can't. So try to take some pride in that fact. And if you do those, study hard, ask questions when you don't understand things, attend your instructor's office hours, you use the resources available to you at your given university, there's a very good chance you'll be able to pass linear algebra. It's considered maybe a weed out class for some majors like engineering, computer science, but it really doesn't have to be. It's not impossible. So my advice to you is to keep these things in mind, study hard, do all that other stuff I said, and you should be able to pass linear algebra, or whatever advanced math class is giving you fits. So, thank you. Enjoy the rest of your break, and unfortunately we'll all be back, at the university soon enough. So, see you later.